In this experiment, the VCC pin of this is LDR sensor. The VCC pin of LDR sensor is connected to VCC pin of Nodemcu, and ground pin of LDR sensor, it is connected to ground pin of Nodemcu, and out pin of LDR sensor, it is connected to A0 pin of Nodemcu, and LED anode is connected to D4 pin, and cathode is connected to ground pin. Now there is a sufficient light on LDR, so the LED, or you can say the bulb, is off. Now I'll close the LED. See, the LED is on. So when I open it, LED is off. It means that when there is dark, bulb glows. When there is light, bulb is on off. So this project you can use it in a street light. So when there is in the morning and afternoon, bulb will be in off condition. When the light falls below the threshold value, then the bulb or LED glows. This is an experiment to interface LDR sensor with Nodemcu. The circuit diagram for LDR sensor with Nodemcu is here. The anode of the LED is connected to D4 pin, and the cathode is connected to the ground pin of Nodemcu. And LDR sensor has got 4 pins: VCC, ground, out, and invert pin. And the VCC pin is connected to VCC pin of Nodemcu. Ground pin is connected to ground pin. Out pin is connected to A0 pin of Nodemcu. And invert pin is left open. It is not connected to any one of the pin of Nodemcu. And this is about connection diagram. So 3 things you should keep it in mind. 3.3 volts of Nodemcu is connected to VCC pin of LDR sensor. Ground is connected to ground pin of LDR sensor, and A0 pin of Nodemcu is connected to output pin of LDR sensor. Let me explain what is LDR sensor. LDR is a light dependent resistor, and it is commonly used for project for creating light sensitive or ambient light monitoring system. So you can connect this LDR to Nodemcu to measure the intensity of the light, and you can take action based on the detected light levels. If you don't have LDR sensor module, you can connect the LDR to Nodemcu directly. Connect one leg of LDR to the Nodemcu analog pin, A0 pin, and other leg of LDR has got 2 legs. One leg is connected to A0 pin, and other leg is connected to the 3.3 volts, that is VCC pin of Nodemcu. And one more thing you should do, connect a 10 kilo ohm resistor from the same leg of LDR to the ground pin of Nodemcu. So make sure all ground, Nodemcu, LDR, resistor, they are all connected to each other. Ground points are connected to each other. So in this way also you can do the experiment. But since I have got the LDR sensor module, so I am directly connecting VCC to this, ground to this, and output pin of sensor to A0 pin. This INV inverted pin, this is inverted output. It is optional, and this pin may not be necessary for most of the application. It provides an inverted output of sensor reading. So whatever you are getting at the output pin, the inverted output you will get at this pin. So you can leave it unconnected if you don't need this inverted output at all. So you kept open. We all know that LDR sensor or LDR itself, it produces higher resistance when exposed to more light. When there is light, its resistance is high. and it produces lower resistance when it is exposed to less light. So when it is dark, it will have less resistance. When more light is there, it produces high resistance. But when we use invert pin, the sensor can do the opposite work. So where it produces high resistance in the dark and low resistance in the light. So this is the feature of INV pin. And in order to get the stabilized readings, you can add pull down resistor, that is 10 kilo ohm resistor, between this out pin and the ground pin. So you can connect one 10 kilo ohm resistor between out pin and a ground pin. So this will help you to stabilize the readings when sensor is not illuminated. So that also you can do. But in this experiment, I am not using 10 kilo ohm resistor. Ensure that the sensor is exposed to stable lighting conditions. So if there is a rapid change in the light intensity, it can cause fluctuations in the reading. So the LDR is, it is also known as a photoresistor. It is a type of passive electronic component, and it changes its electrical resistance in response to change in the light intensity. So the LDR are made from semiconductor material, and it exhibits photoconductivity. And it means that electrical conductivity changes with the amount of light when they are exposed to. In the absence of the light, or when it is exposed to low light levels, the resistance of the LDR is relatively high. Because of that, the limiting the flow of current through it. This resistance decreases as the intensity of the incident light increases. And the applications of LDR are, they are used in various applications where the light intensity need to be detected. And LDR are used in ambient light sensing applications. For example, they can be used in outdoor lighting systems. Why it is used? To automatically turn off the lights, turn the lights on and off, in the evening time on and morning time off. So in such application, you can use it. And LDR can be used in security system also to detect changes in ambient light, which might indicate a breach or any intruder. So for that purpose, you can use it. And you can use LDR to adjust the camera exposure settings. Based on the available light, you can use it. And LDRs are used in solar panel also to optimize their position towards the sun, to maximize the energy collection. For that purpose also you can use it. And they are mainly used in street light system to automatically control the brightness of the street light based on the natural light conditions. And LDR can be used in agriculture also to monitor the light conditions in greenhouse. So they can be used in agriculture. And LDR can be used in consumer electronics, such as automatic night lights. For that purpose, we can use it. And LDR can be used to measure light intensity in industrial application also, scientific and industrial applications also, we can use the LDR. So this is all about the applications of LDR. Now I'll explain the code. Here LDR pin equal to A0, the analog pin where the LDR is connected. And this is a digital pin, D4 pin, where the relay module is connected. Why I am using relay module? Because to the relay module, you can connect your AC bulb also. So the same code is valid to turn on LED and to turn on the AC bulb. If you want to connect AC bulb, connect through the relay module. So, single bulb means single channel relay module you use, or if you have two bulbs, two channel relay module you can use, or else you directly connect LED to the D4 pin. So anything you can do. That's why the variable name I have taken as relay pin. And after that, pin mode, I'm making this relay pin as an output pin. And now to turn off the bulb or to turn off the LED, we are using this command relay pin comma low. So we are using a serial monitor to see the readings. So for that purpose, the baud rate is set to 9600. And in wide loop, okay. So using this command, you can read the analog value from the LDR and print this LDR value to the serial monitor for debugging purpose. And here we are setting the threshold value for the darkness threshold value. I am setting it as 500. You can change here depending on your readings. You get it on the serial monitor. You can adjust the value based on your environment and define this threshold value to determine when it is dark. So you determine this and you can change this value. And check if it is dark or if it is below the threshold value. So I'm setting the threshold value as 500. If it is too dark and if the threshold value is less than this, the LDR value is less than this threshold value, then turn on your bulb or LED. Else, turn off your bulb or a LED. Okay, so after that, you can add a delay here. So I'm adding some delay for stability. You can adjust this as you need it. You can, for every 1 second or every 2 seconds, if you want get the reading on serial monitor for every 2 seconds, you make it as 2000 or 3000. Depends on you, you can do it. So this is all about the coding. After typing program in a Arduino IDE software, you select the port. Nodemcu is connected to COM3 port and select the board Nodemcu 1.0 ESP12E model. How to select? Go here and select the board here. After selecting these two, click on upload button. So after uploading, 100% uploading is done. Go to serial monitor. And now it is showing 13 value because I have covered the LDR. So the resistance decreased. Now I'll make the LDR to expose to the light. See, so its value is increasing 648. Now I'll close LDR. Its value is decreasing 13. So when resistance decreases, the LED which is connected to the Nodemcu is turned on. When it is exposed to the light, its value is becoming 649 and 648. So the LED or bulb which is connected to the Nodemcu is turned off. In this way, we can interface LDR sensor with Nodemcu.